Okay, Alok, so let's start your heat transfer snap, and you are preparing for Bihar Public Service Commission Assistant Professor.
Right, sir. Interviews.
Okay, so what is heat transfer?
So heat transfer means the energy which is transferring from one equilibrium state to another equilibrium state. So basically in this we need to, or we used to determine the rate of a particular transfer of energy. So that comes under the heat transfer. So we talk about the rate at which that heat is transferring. So that comes under the heat transfer.
You know, the heat transfer by conduction is directly proportional to the thermal conductivity, or it's directly proportional to the temperature gradient, and it is also directly proportional to the area perpendicular to direction of heat transfer, according to Fourier's law of heat conduction. We know.
Right, right.
But suppose if you are taking any particular material, you know, for that the more is the conductivity, less is the temperature gradient.
Okay, sir. Right, sir.
Yes or no?
Yes, sir.
If the conductivity of a material is more, then temperature gradient will be less.
Right, sir. Right, sir.
Then these two things are looking like different. One is saying heat transfer is directly proportional to temperature gradient.
Yes, sir.
But if the conductivity is more, temperature gradient is less. So how you
Sir,
will justify
basically, I think basically in this, suppose, sir, we have the temperature gradient will be more, then thermal conductivity will be lesser, right, sir?
yes.
Temperature gradient will be more. It means from
Conductivity
that
is less.
different.
Conductivity is less means the ability to conduct the heat is lesser.
Right, sir. Right, sir.
You are saying heat transfer is directly proportional to temperature gradient. But if
Yes,
temperature
sir.
gradient is more, the conductivity is less, means ability to conduct the heat is less.
Sir, it is saying about the rate of that particular, sir. Del T upon del X is saying about the suppose our dx is fixed, so the temperature potential, so temperature potential in this particular will be more if thermal conductivity will be less. It means the difference between the 2 points is more here, right, sir? The temperature difference between the 2 points are more here. If the thermal conductivity will be less, temperature point, the difference between these two temperature points will be more. That's why, sir, it is like this.
Actually, so okay, later stage I will tell you, don't worry. So, what is the difference between conduction and convection?
Sir, first of all, both are the mode of heat transfer, and conduction generally happens in solid, and which is mainly due to the temperature difference associated with the molecular movement and free electron transfer also. And so molecular movement is lattice vibration and free electron transfer also. Basically, in free electron transfer in solid is more dominant as compared to that lattice vibration. So this is a conduction, and convection is basically happening in between a solid and a immediate surrounding, that is solid and a fluid, and that is in that sir, temperature, that heat transfer is directly proportional to the temperature difference and directly proportional to the area under exposure, sir.
Suppose if you consider a glass,
Right.
and you are increasing the temperature of the glass. So what do you feel? By increasing its temperature, its conductivity is going to increase, decrease, or remain constant?
Sir?
For a glass, you know,
Right,
normal glass which you are having,
right, sir.
what do you feel? With the temperature, its conductivity is going to increase, decrease, or remain constant?
Thermal conductivity. If you will increase the temperature, then, sir, sir, as the thermal conductivity is a property of the material, so upon increasing temperature, it will remain fixed only, and the uh, convection H value will increase, sir, there, because here the
So
transfer is between the solid.
conductivity does not changes. You heard about variable thermal conductivity.
There is a variable thermal conductivity, that is 1 plus alpha T and 1 minus alpha T, both, sir.
Conductivity
And
varies with temperature.
right, sir, it varies with temperatures.
Obviously, with very small temperature, there will be no such major changes. But
Right, sir.
conductivity varies in general with temperature. So
Right,
in
sir.
that context, I am asking you, Alok,
So that
conductivity,
will all, so
uh,
that will depend upon.
if you will consider the variation in conductivity with temperature, what do you feel? It is going to increase, decrease, or remains constant with temperature?
So that will depend upon the value of alpha, that is thermal expansion coefficient, and so this I'm particular got stuck in this side.
अच्छा, नॉन मेटल्स का कंडक्टिविटी, इट्स अ नॉन मेटल ऑब्वियसली, इट्स नॉट अ मेटल,
Yes
ग्लास।
sir, glass.
तो
It's
नॉन
a
मेटल्स का
amorphous.
कंडक्टिविटी
It's
क्या
an
करता है?
amorphous.
नॉन
Sir,
मेटल्स का कंडक्टिविटी टेम्परेचर के बढ़ने से बढ़ता है घटता है?
uh, sir, नॉन मेटल का टेम्परेचर के बढ़ने से घटता होगा, बिकॉज वहां पे uh, वहां पे जो हमारा जो वाइट्स होता है सर, उसका गैप ज्यादा होता है, और मेटल्स में वो वाइट्स बहुत कम होता है, ऑलमोस्ट ना के बराबर होता है। अगर हम टेम्परेचर बढ़ाएंगे तो मॉलिक्यूल्स कोलाइड करेंगे, तो उनके वॉइड्स का डिफरेंस कम होगा, तो कंडक्टिविटी बढ़ेगी, सॉरी सर, कंडक्टिविटी बढ़नी चाहिए।
नॉन मेटल्स का कंडक्टिविटी बढ़ेगी, बढ़ेगी घटेगी? फाइनली व्हाट यू वांट टू से, इट इज गोइंग टू इंक्रीज और डिक्रीज?
सर इट विल इंक्रीज अपॉन इंक्रीजिंग टेम्परेचर, इट विल इंक्रीज ओनली।
ठीक है। You heard about compact heat exchanger? Hello?
सर कॉम्पैक्ट हीट एक्सचेंजर, compact heat exchanger means sir whose effectiveness is equals to 1.
Effectiveness equal to 1? No. अच्छा, मेरे को बता सकते हैं what is Grashof number?
Sir Grashoff's number, sir Grashoff's number we used to use it, it is a ratio of buoyant force upon inertia force, and we use it in sir free convection.
So on what factor Grashof number depends?
Sir Grashoff's number will depend upon so I'm forgetting the formulas for that particular GB delta T upon L square. Some formulas
अच्छा,
there.
characteristic dimension क्या होती है? What do you understand by characteristic dimension?
The characteristic dimension means the flow physics which is happening, exactly the flow physics. Suppose a fluid is flowing over a surface, then if you will say that if you are taking the length as a characteristic dimension, then that particular flow which is happening, right sir, that covers that particular solid. So we used to take it as like that. So like
अच्छा,
in case of
free or natural convection में suppose you are having a rectangular plate like this,
right sir,
तो क्या होगा? What will be the characteristic dimension?
sir, it will be that will be totally, it will be for 3D, it is 4 times volume upon area weighted area, that is 4 times volume upon weighted area.
4 times volume upon wetted area.
Right, so that will be the
volume
characteristic
upon
dimension.
wetted area पैरामीटर, ये तो कुछ इंटरनल फ्लो में आती है टर्म्स, और वो भी वॉल्यूम अपॉन वेटेड एरिया नहीं होता, वो होता है आपका 4a by p, 4 into
Sir
cross
a,
sectional area by wetted perimeter. That is the characteristic dimension formula for internal flow.
so that we used
4a
to
by p.
use it for 2D, right sir, 4 times area upon parameter, that we use it for 2D 2D, suppose 2D object is there, for that we are
Pipe is a 2D object or 3D object?
no sir, no sir, pipe is a 3D object. If we project it, then we used to take it, because if you will say that 4 times area upon parameter for pipe, also it will come diameter, and if you will say 4 times volume upon weighted area, then also it will come as a diameter.
But this is a case of natural convection, no? This is not a case of forced convection, and this is not a case of internal flow. This is a case of external flow.
Yes sir, so then it will be the length of that particular.
What is bulk mean temperature?
Sir bulk mean temperature means sir bulk mean temperature means sir the average temperature of by which the fluid is flowing. Sir suppose we have a pipe, so in pipe we have these two this velocity profile as well as this thermal boundary profile. So in the thermal boundary profile we used to denote it means that the mean velocity, sorry, the mean temperature.
Alok, what do you understand by gray body?
Sir, gray body means gray body is such body who's independent of wavelength, and they have a same intensity in all possible
What is
hemispherical
independent
direction.
of wavelength? What is independent of wavelength?
Independent of wavelength means the emissivity is not a function of wavelength.
So emissivity is constant.
Yes, sir. Its emissivity will be constant, and that will be equals to absorptivity, sir. Alpha.
According to what? Emissivity is always
According to Kirchhoff's law. According to Kirchhoff's law.
so it is always equal to absorptivity, or under some particular condition emissivity is equal to absorptivity.
Sir, when the body is black body, then only it will be, sir.
Black body absorptivity is equal to emissivity, not for other.
No, sir. Sorry, sir. Sorry, sir. The condition was. I'm forgetting, sir.
Body is in thermal equilibrium. If it is in thermal
Sir.
equilibrium, then only you can say that.
Yes, yes.
Okay. My last question is to you,
Sir.
Alok. What do you understand by thermally developed flow?
So thermally developed flow.
Yes.
So thermally developed flow means sir, thermally developed flow means such flow in which that thermal boundary profile means that is not changing. That is remains constant as the flow is moving. So that the thermal boundary layer will be constant. Means the temperature gradient is not changing. It is the temperature gradient is equal for the subsequent direction of the flow.
What is Biot number?
So Biot number, basically Biot number we define as per the formula. It is an internal conductive resistance to the external convective resistance, and we used to say that it should be below 0.1 for lumped heat capacity analysis. And sir, basically it is the formula. The overall formula is h into this characteristic dimension upon k of the solid. And sir, it resembles with that Nusselt number, because in Nusselt number the formula is almost same, but there k is k of fluid and here k is k of solids.
Okay.
And sir, it is not a property. It is not a property. Biot number is not a property.
So Nusselt number is a property.
So Nusselt number, no sir. Nusselt number is Prandtl number is a property. Nusselt number is also not a property.
Okay. So what do you understand by local Nusselt number and average Nusselt number? What is the difference?
Local Nusselt number and the average Nusselt number, sir, while determining that value particular, suppose local Nusselt number means a particular, if you can find one particular point or one particular control volume, then we used to find, suppose Nusselt number is equals to 0.332 into Prandtl number into Nusselt number, sorry, Reynolds number to the power n and Prandtl number to the power m. That will give me that local Nusselt number, and when we integrate it for overall domain, then we got it for the average Nusselt number.
Okay. Look, I think now I can provide you
few more questions, sir. So few more questions, if you allow me, sir.
Again, you can join. I will ask you some more questions. Don't worry.
So one, two, or max 2 questions, sir. Max 2, if you sir allow me, sir.
This time I did this right now. Look, so you can again join. There is no such limit for snaps. You know, any number of times you can join. Okay.
Yes, sir. Okay,
so
sir.
I think there is sufficient time we are having. Now, when is your interview?
Sir, the date haven't came yet,
Yes,
but sir, probably first week of September or second week of September.
So we are having entire August, na? So we are having more than 1 month. So again, you can prepare and you can join me. Okay?
Sir.
So thermally developed का मतलब क्या होता है? When the temperature or what you can say heat transfer is uniformly distributed in the entire cross section, or what you can say when the temperature profile is not changing in the flow direction, that kind of flow is known as thermally developed flow. So initially when the fluid is going to enter, the TBL is going to grow at upper surface also, lower surface also, in the entire cross section. The TBL thermal boundary layer is going to grow. So you will reach to a point where all those TBL thermal boundary layer they are going to meet. And then we can say that the heat transfer effect, so penetration temperature penetration is there in the entire cross section, or heat transfer is now penetrated into the entire cross section. Then you can say the flow is now becomes fully developed. So at that point I already mentioned Kirchhoff's law में thermal equilibrium होना चाहिए. So if your body is in thermal equilibrium, then only you can say that absorptivity equal to emissivity. Biot number you answered, वो आपने ठीक आंसर कर दिया था. Nusselt number local में और उसमें क्या फर्क है? So you know Nusselt number is a function of x. It is going to change with the x, means the flow direction, or what you can say distance from the leading edge. So if you are measuring Nusselt number at a particular distance from the leading edge, that is known as local Nusselt number. But if you are taking average of all those, then what you will have? You will have average Nusselt number. So Nusselt number, Reynolds number, these numbers changes with x. But whereas Prandtl number is a property of a fluid, that is not going to change with x. That is independent of x. Gray body, चलो आपने बता दिया था. Bulk mean temperature. Grashof number is G beta delta T L Q by nu square.
So I forgot that formula actually. So it's
ratio of the product of inertia force into buoyancy force by square of viscous forces. If you take inertia force, buoyancy force, and viscous forces, you will get this relationship, Grashof number.
So
No, glass is a non-metal. Non-metals का conductivity क्या करता है? बढ़ता है due to increased lattice vibration at high temperature. At low temperature, lattice vibration will be less. High temperature, lattice vibration will be more. So for any kind of insulating material, glass, non-metals, conductivity increases with the increase in temperature. But in case of metals, conductivity decreases. Why? Because at high temperature, lattice vibration will be more. But that increased lattice vibration is going to restrict the passes of free electron. So that's why for metal conductivity decreases, but for non-metals conductivity increases. बाद में आपने आंसर कर दिया था, but initially you are having some confusion.
So in that particular, so as we have read that non-metal is classified in two ways. One is the non-crystalline, and one is the amorphous, right, sir? Like quartz, glass, something, right, sir? So I thought that, sir, in case of non-crystalline, we have this this diamond, sir, which is having a perfect orderly arrangement, right, sir? Because there is no gap. And when we talk about amorphous, there's a gap. Like glass is an amorphous material, so there's a gap between that two, right, sir? So I thought that, sir, when temperature is increasing, so these two molecules is collide. So definitely there will be a collision.
Their collision is going to increase. Na? At high temperature, the collision will be more. So if the collision is more, the heat transfer by that collision will be high. So conductivity is going to increase.
Right, sir. And sir, for metals, it is upon increasing the temperature, the thermal conductivity will decrease.
And the collision is going to increase in metals also.
Right, sir.
Metals also collision is going to increase, but that increased, motion, that is going to restrict the passes of free electron. In metals, the dominating part is what? Conduction.
The free electrons. Free electrons.
So free electrons will not be able to flow easily. They will not be able to jump from one shell to another shell easily if the lattice vibration is very high. Are you getting? So lattice vibration is going to increase even when you are having a metal case, non-metal, or any other substance. Conduction, convection, the difference I asked you, I think that you explained.
So one thing you asked me, that compact heat exchangers.
Compact heat exchanger क्या होते हैं? The heat exchangers which are having very lesser area. For a given heat transfer, the area required is very, very less. So there is a factor actually we define in terms of the volume to area ratio also.
Right.
तो area इनका क्या होता है? मतलब इनका जो size होता है, volume, what you can say, area is higher. For a given volume, the area is higher. Given volume के लिए इनका area क्या होगा? ज़्यादा होगा. If the heat transfer will be more, they are very much effective, good effective. But you cannot say the effectiveness is equal to 1. But their size are very less. They're going to occupy the very less space. Okay. But are you getting? As compared to any other area, they're going to. There are some famous types of those kind of compact heat exchangers like plate and plate type होते हैं आपके. Plate and use. I think these are the questions I asked you, and I started with heat transfer that you explained what is heat transfer. So any other thing if you want to ask me, Alok?
Sir, actually, sir, last time when day before yesterday, I had this thermodynamics snap with you, sir. So that day you told me that I have explained well only, but the things I should be calm while answering things. Means properly I should answer. So that day you told me that you can have a snap day before, after some days, like 2 days, 1 day, whenever you want. So sir, can we have this snap interview for thermodynamics also? Because sir, actually I am a PhD scholar, sir. In the morning time today I got this. That's why I got a holiday from the college, sir. So sir, can I have this thermodynamics snap also?
No,
If sir, if you are
for,
free, else otherwise no issue,
for
sir.
that you need to join me tomorrow only. Alok.
Okay,
This
sir.
time it is
Tomorrow
not
at
possible. Yes. Tomorrow you can have.
the same time, right? Sir, night.
Same time, 3 p.m. Yes.
Sir, how you will rate me for this out of 10? How much you will
It is
rate me
better.
for the
It
heat
is
transfers?
your performance is improving. Alok. It is
Sure,
better
sir.
as compared to your earlier performance. But don't worry. Don't think of those kind of things. Just
Sir,
focus on improving. Just focus on where
right,
you
sir.
are lagging actually. Okay.
Sir, sir.
अभी reading waiting में मजा it's good. But yes, further you need to improve your delivery. थोड़ा आज भी थोड़ा जल्दी लग रहा था. You're not taking much time actually to think. थोड़ा आप confused हो जाते हो when you get the question.
Right.
It's look like you are in very hurry. So take just think for a sufficient amount of time and then only start answering. ठीक है?
Right, sir.
Same observation. But ठीक है, it's better as compared to your earlier performance. ठीक है, Alok?
Sir. Right.
Okay, good luck.
Thanks a lot, sir. Goodbye, sir. Thank you, sir.